Yeah, the whole
on
calories thing
this
is such a like it's such a scam, honestly. It's
cemented
the
in stone.
I know, and if you say that, oh, calories are not, it's nothing but calories, then people like in the medical profession, they think you're automatically like a quack because they can't understand. And I always think this is very strange because if you simply say, okay, like look, there's foods which are composed of macronutrients, proteins, fats, and carbohydrates. So yes, they have calories, and people always say a calorie is a calorie, but it's like okay, but that's not what I asked you, right? I didn't say is a calorie a calorie. What I want to know is are all calories equally fattening? Like are they all the same? Because you know that if you take a plate of cookies and a plate of salmon, even if they're the same calories, the minute you put it in your mouth, your body responds completely and utterly differently. Okay? We can measure all these things. No problem. You eat cookies, your blood sugar goes way up. Okay? That's not controversial. Your insulin is going to have to follow because it's going to
Mhm.
force all that glucose up, right? You eat something like fatty salmon and avocado, for example, same calories, your insulin's not going to go anywhere. Your blood glucose is not going to go anywhere because it's a lot
And
of
half an hour
dietary fat.
later, you're
Yeah,
not
and
going to
half
be
an hour later, you're
starving.
not going to have the low. So the hormonal response, and then for example, if you eat salmon, you're going to have protein, you're going to have fat, so you're going to have satiety hormones like peptide YY and cholecystokinin, which are going to be released, but not with cookies, for example. So there's a completely different response in our hormones from two different foods that is completely irrespective of calories. So what is important about those calories? Like does our body somehow detect those calories? It's like no. There are no receptors for calories. Your body doesn't know how many calories goes in and out of your body, right? It's weird because if you look at any metabolic pathway, so go to the biochemistry textbook and say, okay, here's the metabolic pathway for glucose. And here's the metabolic pathway for amino acid degradation. And here's the metabolic pathway for fat. So dietary fat, for example, gets absorbed. It goes into the chylomicrons, which goes through the lymph to the blood, which goes to the fat cell, the adipocyte, and you activate LPL. There's a whole pathway. And it's been worked out for like 50 years. Nowhere in there is there calories. Calories are completely irrelevant. There is nothing that the body just doesn't care about calories in any shape or form. And yet we think it's the most important thing for weight loss. It's like, why would you think that? Like, it's really, really bizarre because it's completely unphysiologic. Because you have to remember that calories is a unit of energy from physics. A calorie is the amount of heat that is released when you put a food, like you put that salmon into a bomb calorimeter, you burn it, and how much energy is released. That's what a calorie is. So people say, well, it's the first law of thermodynamics. I was like, okay, that's also completely wrong because if you take in, so, the first law of thermodynamics says in a closed system, you don't create or destroy energy. But that has no relevance, again, to the human body. If you take 100 calories of food, you put it in your mouth and you absorb it, then your body can either store it as fat or it can use it to build protein. Or it could burn it off as energy and, increase your body temperature, for example, or use it to power your liver, your brain. So so those same calories can have completely different things, and it still doesn't break the first law of thermodynamics. I mean, people talk about, they say body fat equals calories in minus calories out, right? That's the energy balance equation. And that is true, but always misinterpreted. So if you say that body fat equals calories in, calories out, you're assuming that the calories in, when you reduce those calories in, calories out, the basal metabolic rate remains stable. But it doesn't. Like,
It doesn't.
this is, again, just ridiculous because we've known for 20 plus years that the metabolic rate does not stay stable. It goes down. When you reduce calories in, calories out goes down. So if you eat 500 less calories in and your body burns 500 less calories, you are not going to lose body fat. So that's not breaking the first law of thermodynamics. It's just the way the human body works. And that's why people don't lose weight when they try to eat less, move more. Because what happens is that the body simply changes. So you eat less, you eat 500 calories less, your body burns 500 calories less, and you don't lose weight. And then eventually you get tired of it, so you go back up a little bit on your diet. So you say, okay, instead of 500 calories less, I'm going to eat like 200 calories less. So you're still eating less than before. But your body is now burning 500 less. So even on that lowered diet, your weight is going back up. So again, it's not the calories that's important. It's an almost irrelevant thing. What's important is the hormones in our body that are telling us whether we're hungry, whether we're not hungry, what our basal metabolic rate is. That's what's important. You got to focus on the hormones because our whole body works on hormones. That's just physiology. It doesn't work on calories and physics. It works on hormones. We respond to hormones. If your insulin goes up, there is a predictable response as to what will happen. If your peptide YY goes up, there is a predictable response as to what is going to happen in the body, right? And different calories will do different things. So this whole idea of calories is so, like, the more I think about it, it's like the more stupid it seems. Like, it's
And the
so,
sad thing is
like,
that
juvenile.
we